Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to discuss the part A, that is question 1 to 10 of the JAM 2024 chemistry paper that was asked this year. Okay, so these are some of the topics that were asked in the first 10 questions. That is based on the structure of amino acid, how to find out the complex conjugate of a particular given wave function, and one question was based on SN1 reaction. So these are some of the questions that were asked. So the first question is, the following dipeptide derivative is used as an artificial sweetener. The constituent alpha amino acid of this dipeptide are. Now why this is called as a derivative is that we have to understand. Suppose this is amino acid 1, okay, and this is amino acid 2. Okay, they are linked by which bond? We know it is a peptide bond. And what is exactly a peptide bond? It is amide linkage, CONH. So you have to find out this amide linkage first. Okay, dipeptide means there are two amino acids and one peptide linkage. So you can see here, this is what? This is the peptide bond or peptide linkage. So how do you identify the amino acid? Based on the R group. We know carbon, that there is one R group, then there is amine group, okay, carboxylic acid group, and then there is one hydrogen. Okay, so this is a basic Zwitter ionic form of the ion of any amino acid. We identify based on the R group. We identify the amino acid based on this R group, or we call this as a side chain. Okay, so let us identify the side chain. So here, if you see, this is C double bond O. Here it would have been COOOH, carboxylic acid. Okay, CO2H, CH2, NH2, C double bond O. This is the first amino acid. So here you can see the side chain is CH2, CO2H. So this is which acid? There are two acidic amino acids. Okay, in this structure you can see there are two acidic groups. So this is called as acidic amino acid because carboxylic acid group is more as compared to the amine group. So this is which group? This is called as aspartic acid. Okay. This we had also seen. Suppose there are two methylene groups, CH2, CH2, and then there is CO2H. This is called as glutamic acid. Okay, so you can remember this is a longer chain and G comes after the later in the alphabetical order. So that is how you can remember this. CH2OH, this is a smaller chain, and in alphabetical order also A comes first. A comes first, smaller chain, it is aspartic acid. G comes later, then this is 3 carbon, longer chain, then it is glutamic acid. Okay, in this way you can remember the name. So this is aspartic acid. What will be the other amino acid structure? NH, that is NH2. Okay, if the C double bond O, this is derivative. Why this is called derivative? Because here if it is carboxylic acid group, then we say it is a amino acid. Now here this is what? Esterified, that is ester is formed, esterification reaction has occurred. So we can write C double bond O OH. This is which amino acid? If there is only benzene ring, then this is called as, okay, if there is only R group, okay, if it is CH3, then we call it as alanine. Okay, if I replace one of the hydrogens with phenyl ring, what this will be called? This will be called as phenylalanine. Okay, so the correct answer is phenylalanine and aspartic acid. Phenylalanine and aspartic acid. So the correct answer will be option B. Okay, now let us see the next question. The suitable reagent combination for the following transformation is. So what we can do is we can draw the reactant and react it with all the reagents. So we will come to know which is the correct answer. The first reagent given is MCPBA. Okay, will this react? No. Okay, MCPBA is generally used for what? It is used for either epoxidation, or another thing is if there is a ketone that is present, we can convert it into a ester group. Okay, this is Baeyer-Villiger oxidation, BVO. This is what? This is called as epoxidation. Okay, so here alkene is not present, so this reaction cannot take place. This can take place. Now the question is where the oxygen is inserted. Oxygen is inserted at the electron rich group. In between the, okay, which group is electron rich here? Okay, this group is the electron rich group. Okay, methyl group is electron donating plus this R group. Okay, so the structure formed will be an ester group. Okay, methyl and one oxygen will be inserted here. C double bond O Me. So is this the structure that is given? No. Here we want carboxylic acid. So option A is incorrect. Okay, now let us draw the structure for option B. What is the role of option B? If there is some alkene that is present, if you add OSO4, what will happen is dihydroxylation takes place. Means two OH groups are added and it is a syn dihydroxylation. That means the stereochemistry should be same. Stereochemistry of both OH should be same. We can use OSO4 and sometimes potassium permanganate KMNO4 can also be used for the same thing. What is the name of this reaction? This is called syn dihydroxylation. Di means two hydroxyl groups are added. That is why this is called syn dihydroxylation. Syn means both the OH should have the same stereochemistry. So this is here there is no alkene group, so there will be no reaction. Third one, yes, third one is a correct answer. This is what iodine plus base. This is which reaction? Iodoform reaction. Okay, and we know in iodoform reaction if there is any methyl ketone. Okay, methyl ketone means one side substituent of the one side of the carbonyl group is a methyl group. Okay, why? Because this CH3 is going to be forming CHI3, that is nothing but iodoform. Okay, so that is why this methyl group should be present. It should be a methyl ketone. Okay, so here methyl ketone is present. Yes. So what happens is methyl ketone, it is basically oxidized to carboxylic acid, C double bond O minus. So you can see it is oxidized to carboxylic acid. So the correct answer is option C. Last option, DMDO. DMDO is also a oxidizing agent. DMDO is a oxidizing agent. Okay, what it can do, let's say there is a secondary alcohol, it will oxidize it to ketone. Okay, so here there is no ketone, cannot be further oxidized by DMDO, so option D is also incorrect. So which is the correct answer for this question? Option C. Now let us see the next one. So here alkyl halide is formed. Alkyl halide reacts with a nucleophile and we get a substituted product. Br is substituted by cyanide. Okay, so the question is which mechanism it will follow. Okay, we have to identify the rate. Okay, so if I draw the structure of this methyl, and then there is pH. pH means benzene ring. Okay, if I remove, okay, Br minus is given. So the first step is what we can do, we can remove leaving group and we will form a carbocation. Now the question is this carbocation stable? The answer is yes. Why? Because methyl group donates electron density via plus I inductive effect. Okay, plus this is a benzylic carbocation, so it will also be stabilized by resonance. Okay, so this is a very stable tertiary and the carbon is the positive charge is present at the carbon next to benzene ring, which is called benzylic position. So this will be called as tertiary benzylic carbocation. It is a very stable carbocation, so this will be formed and the mechanism used will be, mechanism followed for this reaction will be SN1 reaction. So in SN1 reaction we know rate is dependent only on the concentration of the alkyl halide. Okay, because in the first step it is only the alkyl halide that is present. Okay, afterwards, after the carbocation is formed, then the cyanide will attack, that is a nucleophile will attack in the second step. So in the first step, that is a slow step, that is what? That is the rate determining step, only which reactant is present? Alkyl halide. Now the question is, what they are saying is, you increase the concentration of KCN. KCN is the nucleophile. Okay, you increase this by 4 times. Is the nucleophile present in this rate equation? No. So if you increase the concentration of nucleophile, the rate will be unaffected. Okay, because it is a SN1 reaction. No doubt if it was a SN2 reaction, we know in SN2 reaction rate depends on both substrate, that is alkyl halide, as well as the nucleophile. If it was SN2, then the answer would have been increased by 4 times, but here it is SN1 reaction. Okay, so the answer will be unaffected. Option A. Okay, next one. Question 4. Consider the following wave function. The complex conjugate is. Okay, so what is the question? You have to find out the complex conjugate. Okay, it is very simple. It's a question from quantum chemistry. How do you find out the complex conjugate? Very simple. Wherever you find this I, this is called as iota. Okay, wherever you find this I, you can replace it with minus I. Okay, you add a negative sign. Basically, you have to add a negative sign. Okay, then you will get the complex conjugate. N will become N star. Okay, so what is a wave function? Psi x is equal to N. Okay, exponential means I can write it as e raised to. Okay, e raised to I kx plus e raised to minus I kx. Okay, this is the expression. Now, what I will do, I have to write down the complex conjugate. So, psi x, N becomes N star. That is the normalization constant for the complex conjugate. E raised to I will become minus I kx plus e raised to minus I will become minus I. Okay, so minus into minus I will be plus I kx. Okay, so you can see basically we have got the same thing. This term is written first and then e raised to plus I kx written in later on. So we can rearrange N star, we can write exponential at again exp raised to I kx plus exponential minus I kx. So this is the final answer. What is the correct option? Sign is not going to change. This is incorrect. This is incorrect. Plus, okay, N star. This is also incorrect. So the correct answer is what? Option C. Always remember, it is very simple. You have to just write, if it is I, you write minus I. Okay. I, you have to substitute. You have to add the negative sign basically. Okay. So let us see the next one. Question 5. Wavelength of X-rays used in the diffraction experiment is 1.54 Armstrong. So wavelength is given 1.54 Armstrong. Then X-rays are diffracted from a set of planes with interplanar spacing of 1.54. D is given 1.54 Armstrong. Okay, then the angle theta in degrees for first order. First order means n is 1. So we have to use basic Bragg's law of diffraction. N lambda is 2d sine theta. Substitute all the values. N is 1. Lambda is 1.54 Armstrong. 2 into d value is also 1.54 Armstrong into sine theta. This gets cancelled. Sine theta is 2 will come here. Sine theta will be half. 1 by 2. What will be theta? Theta will be sine inverse of half. Okay, or what we can do, for which sine value angle is half, the answer is sine 30. Sine 30 is half. So you compare both these equations. What is theta? Theta is 30 degrees. So the correct answer will be option A. Okay, next question. Question number 6. Identify the reaction for which at equilibrium change in volume of the closed reaction vessel at constant temperature will not affect. Okay, when this happens, when the delta Ng is 0. What is delta Ng? Number of moles of product. Which product? Only gaseous product minus moles of gaseous reactant. This is what? This is 0. Okay, so first one, A option. Here delta Ng will be, gaseous product is 1. This is solid. This is also solid. So 1 minus 0, that will be 1. So here it will be affected. This is incorrect. B option. Delta Ng will be product gaseous. There are 2 moles minus 1 plus 1, 2. So 2 minus 2, 0. So this is the correct answer. C option, delta Ng will be 1 mole. Here there is 2 moles. So 1 minus 2, which is minus 1. This is also incorrect. D option. Okay, very careful. This is gas, this is solid. So 1 minus 0. Okay, so this is also incorrect. The only correct answer for this question will be option B. Okay, so seventh question. There are 4 complexes that are given. The complex that exhibits largest molar absorptivity in the visible region of electronic absorption spectrum is. So this is question of coordination complexes. Okay, or okay, it is basically based on the 2 selection rules. One is delta S is 0. This is spin selection rule. Change in spin multiplicity should be 0. Next is delta L should be plus or minus 1. This is called as Laporte selection rule. Now this is what normally titanium, what is electron configuration? 3D scandium titanium. This is 22. Okay, 3D2 4s2. Now here the oxidation state will be, okay, water is a neutral ligand, so it is plus 3. So remove 3 electron, 2 from here, 1 from 3D. So this is 3D1 complex. So now if you see this is what? This is spin allowed. Okay, after you do the DD transition, overall spin is same. Here also the total spin is what? Half, or spin multiplicity will be 2 into half plus 1, that will be 2. Here also there is 1 spin, so spin multiplicity is 2. So delta S will be 0. This rule is followed, but DD transition you have to remember that D to D. Okay, so D to D means here 0, 1, 2, 3, S, P, D, F. For D, L value is 2. So T2G will also have L value of 2. EG will also have L value of 2. Delta L will be 0. Okay, but the rule says it should be plus or minus 1. So always remember DD transition are Laporte forbidden. Okay, so here what will happen? This is Laporte forbidden, so it will be having less intensity. NiCl4, this is tetrahedral complex. These are what? These are partly Laporte, partly allowed. Okay, Laporte partly allowed. So this will have intensity higher than the first one, complex 1, but still it will be lower. Okay, next we talk about Mn plus 2. Again, this will be D5 complex. D5 complex is what? It is a complex that is spin forbidden as well as Laporte forbidden, because okay, initially these are the 5 electrons. Now here total spin is how much? 5 by 2. Now if I do a DD transition, okay, what will happen? You can see now the spin is how much? 3 by 2. So spin is changed from 5 by 2 to 3 by 2. So this rule is also not followed. So Laporte forbidden, spin forbidden. So this will have the least intensity. Always remember, this will have the least intensity. Okay, intensity means it will also have least absorption coefficient. Okay, epsilon. Molar absorptivity will also be minimum. Okay, the one for which the intensity or the molar absorptivity is maximum is the complexes where there is charge transfer. Okay, wherever there is charge transfer that is present, that will be maximum. So that is option C. Here, this is the structure of CrO4 2 minus. So here what happens is, here you can see Cr oxidation state is what? X minus 6 is minus 2, X will be plus 4. Okay, so here basically what happens is oxygen, okay, oxygen, it has a negative charge. Okay, so this will form the sigma bond, and it is also a pi donor. Okay, sigma donor and pi donor. So this is which type of charge transfer? Ligand is donating the electron density to the metal ion. So this is ligand to metal charge transfer. Okay. So the correct answer for this question is option C. Okay, next one, option 8. Now here you can see, are this linkage isomer? Linkage isomer means something like cyanide. Okay, where the linkage to the metal can be changed. Okay, either the donation can be through nitrogen or it can be through carbon. Cyanide is one example. Another example is nitro group, ONO. Okay, donation through oxygen or donation through nitrogen, like this. So same ligand, there are two donor atoms, but at one time only one can donate and that atom is different. So that is nothing but called as linkage isomerism. Optical isomer, is there any optical isomerism possible here? No, because plane of symmetry is present. Okay, cobalt, there are 5 same ligands. Okay, 5 same ligands, and then there is one sulfate. So here plane of symmetry is present. These are what? Optically inactive. So B is incorrect, C is incorrect. Coordination isomer is possible when there are two coordination complexes like this. Okay, and the ligands are exchanged between two coordination complexes. There will be two metal ions as well, M1, M2, and then there will be certain ligands, L2 and let's say L3. Okay, this will exchange, the ligands exchange takes place. So M1, this will become M1 L3 and this will become M2 L1, like this. The ligands are exchanged. Okay, sorry, here it will be L2. Then it is coordination isomerism. So here what is happening is, inside the ligand is exchanged from the ion that is present outside the coordination sphere. That is why this is called as ionization isomers. Okay, sulfate has come outside the coordination sphere. Bromine is acting as a ligand. So the correct answer is option A. Question 9. The pair of proteins having heme core is. So let us see what is heme core. So heme core or heme complex is iron. Okay, iron plus porphyrin ring. What is porphyrin ring? There are 4 pyrrole rings like this. Okay, there are 4 pyrrole rings. Okay, and then ortho position, there is one methylene substitution, like this. So this is called as the porphyrin ring. And when there is a metal ion, the central metal atom is iron, then this is what this is called as a heme complex, iron plus porphyrin. Okay, so where this is present, this is the structure of hemoglobin. You can see iron is present and the porphyrin complex is also present. So iron plus porphyrin, this is what? Heme. So hemoglobin is one complex where heme group is present. Now what is myoglobin is, if you take, okay, one subunit is nothing but myoglobin. Okay, same structure. Okay, this same structure is present. If one subunit, single subunit if you consider, that is called as myoglobin. Okay, if I take this one heme complex and if I take 4 subunits of heme complex, then it is what we will get? Hemoglobin. So 4 subunits you can see here, then it is called hemoglobin. So the structure is basically the same. So both myoglobin and hemoglobin heme complex is present. Okay. Okay, hemoglobin and myoglobin. So correct answer is option A. Hemerythrin and hemocyanin, both the cases. Here there is a copper, metal is different. In hemerythrin also, metal is iron, but the porphyrin ring is missing. So it is not called as a heme core. Okay, so hemerythrin and hemocyanin are incorrect option. So the correct answer is option A. Last question, the shape of SCN- is. If you draw the Lewis structure of SCN, it would look something like this. Sulfur belongs to group 16. It has 6 valence electron. Carbon, we know group 14. It has 4 valence electron. And nitrogen has 5 valence electron. Here it will have minimum charges. So you can see it is what? It is linear. Bond angle is 180 degree. The correct answer will be option A. Okay, I hope you have understood all the 10 questions, and in the next video we will see questions from the remaining parts. Thank you.